Exercises 36 and 37 use the following definition. If f is from R to R and g is from R to R are functions, then the function f plus g from R to R is defined by the formula f plus g of x equals f of x plus g of x for every real number x. If f and g are both onto, is f plus g also onto? Justify your answer. Now, if you try several examples, usually this is true. When I was testing out examples, I tested out several examples where it does work. But I think there is a clever way of constructing two onto functions that, when added, creates a totally different function. I know I'm basically giving this away, but imagine f of x equals x cubed. This is an onto function because every real number is the result of cubing some number. So for example, if I wanted to get the output 3.7, then we can simply just plug in the cube root of 3.7, and the cube and cube root operations undo each other, so they essentially cancel out. And so f of the cube root of 3.7 is exactly 3.7. The point here, though, is that it didn't really matter what this number was. There's a way of finding an input in the domain of f in particular that maps to the output 3.7 or whatever number you want. So again, in general, if we want some real number z, then we can just plug in the cube root of z. And it doesn't matter if z is negative or positive, since you can take the cube root of negative numbers. Now let's imagine another function, g of x, which is negative x cubed. This is also an onto function because if we want to get z as our output, we can just plug in negative the cube root of z. So for example, if I want to get the output 3.7, in this case, we would plug into this function negative the cube root of 3.7, and cubing a negative number produces a negative number, but this negative here will cancel with that negative after cubing this number, and so we get positive 3.7. So both of these functions are onto, but maybe you know where I'm getting at here. If we add these two functions together, we create a new function, which is f plus g. Now this function is defined by taking the outputs of f and adding them with the outputs of g, which is x cubed plus negative x cubed. But those cancel and we just get 0 here. So f plus g is 0. This function's definitely not onto. Remember that onto means that every element in the codomain is an output of the function. This function here has only one output, and the codomain for f plus g here is r, all real numbers. So if this function were onto, we should be able to get every real number as an output somehow, but that's going to be really hard when all of your outputs are just one number, 0. You're never going to get the output 1. You're never going to get the output 3.7, even though you can get the output 3.7 with f and g individually. Once you add them, they cancel each other out in a really convenient way here, and we no longer have an onto function. To prove that a function is not onto, you need a specific counterexample. So we can say there are no inputs in R that produce the output 1. There's no way we get the output 1 specifically. But notice here I'm providing a specific counterexample. It's always easy to prove that a function is not onto, and it's also easy to prove that a function is not one-to-one. But you still need to provide a counterexample as to why it's not onto or why it's not one-to-one. Thanks everyone, and I'll see you in the next video.